So the next talk is going to be by Alessandro and Andrea. And
Okay, hello everyone. So our talk is going to be about rated ranking evaluator and open source approach for search quality evaluation. The talk is going to be divided in 3 phases: an introduction about search quality and search quality evaluation, a description of the framework and tools we developed, which is rated ranking evaluator, and then a demo showing it. So a little bit about myself. My name is Alessandro Benedetti. I'm a software engineer specialized in search. I work as a search consultant, R&D software engineer, and director of my own company, so a lot of business-related things. I have a master in computer science. I'm passionate about Apache Lucene and Apache Solr, and also on integrations such as machine learning integration with search, and semantic and natural language processing. And in my spare time, in summer I play beach volleyball, and in winter I snowboard. Andrea, my colleague, is a software engineer starting in 1999, hermit, so he usually works remotely and on his own, passionate about Java, and is a committer of Apache Cupid, husband and father, and contributor to all the projects mentioned. So we work at CISA. We are open source enthusiasts. We are based in the UK, in London, but we are geographically distributed, and we mostly work on open source search technologies, in special Apache Lucene and Solr. Our focus as late is on leading to rank, document similarity, and specifically the Apache Lucene more like this, and related integrations, search quality evaluation, which we will talk today, and relevance tuning. And this is just a list of our clients. Okay, so let's introduce what is search quality evaluation, and why it's important. So search quality is important for various stakeholders. So the business would be focused, and for the business I mean the final users and possibly the owners of the business, will be focused on correctness, robustness of the system, reusability, maintainability and extendability from a cost perspective, while the software engineer and the search specialist are going to be interested in search quality from the point of view, are we actually providing the best results to the user? So we use the search technology in the best way. Is it testable? Is it reproducible? And specifically why correctness is important. It is important in the development cycle. So when you have your search team, the developers working on a project, on different iterations of the project, they want to communicate to the business layer, the improvements, or regressions if they happened. And also, they want to be able to show. So it's like, is this costly operation that costed us 6 months for an entire search team actually produce some value? And sometimes just words are not enough, and you need to show not the code in this case, because they wouldn't care about the code, but at least numbers and results. So show, yes, effectively, we improved search quality through these metrics. And this can how you can evaluate search quality. So there are various metrics you can use. Offline measures, which are independent of your search system, and are independent of your runtime search system. So they can be calculated offline. They don't need to be related to your production environment, to your running server. And these metrics are like, we already been talking about that, for example, during the learning to rank talk. So like precision, F-measure, NDCG, recall, mean decibel rank. There are a lot of metrics you can use for offline evaluation of your search quality. And when you evaluate your search quality, you need ratings, of course. So you need a ground truth. You need to know what's good and what's not. And then you can calculate the metrics on top of that. And then you have online measures. You can actually evaluate your running system. So your production environment, you can check, for example, is people clicking on the results? Is people engaged with what we provide? Are they abandoning the search interface? Are they getting a lot of zero results query? So here comes the rated ranking evaluator, which is an open source software to help the software engineer both in the development phase and to justify and show the benefits of recent development to the business. So we started showing RRE in London at the Apache Lucene Solar Meetup in June. At the time, it was just me and Andrea, and the life of the project was a couple of months, so it was a newborn baby. Then at ASTAC, the Relevance Conference by Open Source Connection in London in October, we show the improvement. Of course, like a lot happened. And FOSDEM 2019, because it's not in the past, we had like a growing base of contributors. The RRE is effectively a set of tools, so it is a framework composed by different libraries and different possible integrations. So this slide may be a little bit confusing, but the focus is you have a library core, which is the equivalent of Apache Lucene for Apache Solar and Elasticsearch. And then you have a lot of different components, some of them in the roadmap, some of them already developed, that provide an interaction with the library. Okay, so this is a set. So just to going back a little bit, the different components are going to provide a Maven integration, so you can run like a Maven build to be able to evaluate the search quality of your system. And we talk about offline metrics. So RNRE will allow you to calculate offline metrics on your search system given a set of ratings. So this is a set of the available metrics. It's not so important right now to go through them. So it's just we implemented a set of them. From time to time, we will contribute more, and of course, potentially other contributors come. Let's introduce the way the information is modeled in RRE to allow the user to model the ratings in input that will allow the system to know what's relevant and what's not relevant, and then will allow the system to produce results that are easy to be navigated. So you have an evaluation iteration that will run on a rating set on a specific system that will be characterized by a set of configuration. The system can have different corpora, so you can imagine you have different collections of data, different domains, for example. Within the corpus, you may optionally have different topics. For each topic, you may have different query groups that produce the same results, and each query group can be represented by effectively different queries. And you want to calculate on each query what are the metrics, and then be able also to navigate what's for the query group, the aggregation of the metrics, what's for the topic, corpus, and the full. Not everything is, of course, required. You just require the corpus, so you want to you need to identify the collection you want to evaluate and the query. So you don't need that. If you have the topic, it's better for you. You're going to model the data in an easier way to navigate, but if you don't have it, it's fine. It's not mandatory. So you have an input layer for RRE where you model your ratings. So effectively, you need to build a ground truth. You need to identify your potentially topics, query groups, query, and associate documents to the query with a rating. This can be done, as we've seen in Learning to Rank, you can do that explicitly or implicitly. That's not the focus of the talk, but anyway, we assume that for RRE to work, you have a set of ratings. Then you have the evaluation layer, which effectively is RRE with the internal libraries that will be able to take the rating set and then run the queries against your search engine, and based on the results coming from the search engine, give you back the results. So how is it performing according to the ratings? Then for each iteration that you want to generate, so whenever you say, okay, I want to calculate the search quality of my system, RRE will output the results, navigable in a tree-based structure. So you can navigate like, okay, I want to see the results and higher level, just I'm interested in the topics, I'm interested just in the corpus results, or I want to go deeper. For example, I am a developer, I'm interested in some specific queries that are failing, and I want to explore them. So this is more for an offline use, because the slide is quite intense, but it just shows you the way of working for RRE. So what you can do is, we were talking about the fact that you can evaluate your system. So to evaluate your system at the moment, what you need to do is you need to reproduce the configuration of the system, and RRE is currently compatible with Apache Solr or Elasticsearch. And what we'll do, we'll spin up an embedded instance of your server with the configuration you provide, and use that embedded instance to then calculate the results. So a corpus, as I said already, is going to be a collection. So it can be basically an index, can be an Elasticsearch collection or a Solr collection. Generally, you want to identify the domain, and then you can run the quality evaluation on that specific domain. The configuration sets is what define your search server. So it can be, again, Solr configurations, for example, or Elasticsearch configuration, the index structure, the way you model your queries from a configuration perspective. And then you have like the possibility of defining query templates. So your query can just be a free text search, just query terms, or potentially they can use like specific boosting, additional filtering, and this of course is like various examples. They can be like, they can follow an Elasticsearch syntax, they can follow an Apache Solr syntax. The ratings. So the ratings, you give an input effectively from a RRE perspective are going to be a JSON file that defines the queries, define the document, and then define how relevant the document is for that specific query. So you can specify the gain per document, or you can specify, I have for this rating, this set of documents. And in the evaluation output, you're going to have the same structure you provided in the rating set, so the same tree, and you can explore digging down to the tree hierarchy and seeing the various metrics calculated. Lower level, so leaf level is going to be per query, but you can navigate up to the query groups, topics, and then corpora. There are various ways to see the output. You can have like basically an Excel page with all the results according to what you calculated, or you can have a dashboard currently that we will see at the demo that show you for the different topics, query groups, and query, the various metrics, how they perform in the last iteration, and how they compare with previous iterations. Because of course, it's really important to be able to compare. In the previous iteration, for example, we got an improvement with these metrics, but we got a regression in comparison to a much older iteration, for example. So this is going to be, so there are different aspects. So it's going to be useful both for the software engineer that effectively needs to debug specific queries and debug and also evaluate how the system is performing. And it's also good for the business layer to quickly understand. So they may not be interested in the list of documents per query, so if they're relevant to there or not, but they may be interested that overall the collection is doing well. So even in the last sprint, after 3 weeks of development, we got an improvement in precision by this percentage. There are various questions, of course. It's an evolving system, it's still in development, so it's improving slowly. And there are various questions like, is it possible to persist the evaluation data and then compare them afterwards? I don't use Java, because it's written in Java RRE, but it's possible to be integrated effectively through Maven with other platforms, so you don't really need Java, but potentially if you want to contribute, it's written in Java. And various other questions that we'll skip for now, and we'll go with the demo, which is going to be presented by Andrea, that will show you a use case of RRE So starting from the book Relevant Search by Doug Turnbull, we will follow some examples from the book, seeing how you can check the search quality of your search system, understand where are the pitfalls, approach like with modifications in the configurations, and then see how they contribute to the improvement of the system effectively. You can, no. Just to give you additional information, this is going to be available in our GitHub repository from our company. So you have the project that we're going to show now and in the demo. Easy to be downloaded, and you can check on your own how you can like produce the different results in the search quality evaluations. You will see the different configurations we're going to use, and the tuning operations, the way you modify the query, for example, or the index configuration.
So, good afternoon. I'm Andrea Gazzarini, the guy you've seen in the previous slide. And first of all, it's my fault, FOSDEM 2018. I'm the responsible, and I will change later. And as Alessandro said, this is a brief walkthrough for demonstrating, how RRE can be used for doing some search evaluation. We provided in GitHub, in our GitHub repository, demo repository, so you can have a look, you can download it, you can play with it. What is it? It's a RRE-enabled project, basically. There's no Java code because RRE is written in Java, but you don't need to know Java because we have only a couple of requirements, Maven and Java, of course. But all what you need to do is to provide, of course, all those files or data that Alessandro said, and that has nothing to do with Java. And you need to run some commands because at the moment the RRE, as Alessandro said, is there is a core, but the runtime container, the implementation is basically a Maven plugin, so you can inject the quality evaluation process in your build process. And for this demo, we used some examples from Relevant Search with the dataset, which is an extract of the TMBD. And we are using, like what happens in the book, Elasticsearch, a specific version of Elasticsearch 6.3.2. So the index shapes, the schema, the Elasticsearch schema, and the query shapes are coming from that book and are Elasticsearch queries. But if you want to start a new project, if you want to create an RRE-enabled project, there is the wiki, the RRE wiki, which explains exactly how to do that. We can try now, but it's just a matter of the only thing at the moment is our dependencies are not in Maven Central, so you need to configure in your Maven settings the CIS repository, but in the wiki there is all explained. So we can create. Oh. Yeah. Yeah. Okay, I should have. We basically provide as part of the RRE itself a module which is a Maven archetype which gets, of course, some parameters related with the search platform that you want to use, Solar or Elasticsearch, which version, your group ID, your artifact ID, and This is in, sorry. Demo effect. Yes, this is with success. So at the moment, I've created an RRE-enabled project that can I load in my IDE. Open. And here, just to have a brief look, this is what it creates. You can see that there are under the source ATC folder, which is the default, but you can change it through the archetype, several subfolders. Each folder contains those data that Alessandro explained. So the configuration sets that are specific to Elasticsearch, the corpora, which is a sample corpora, is not the TMBD here, but is just a sample and following the same path, the rating example, and some query templates. The archetype also provides a couple of sample iterations, 1.0 and 1.1, with some configuration. This is the basic configuration, and here in the second iteration, the user decided to add the stop words. So under each folder, there is a README file that explains, what is supposed to contain the folder. And in the Maven POM project object model file, you can see how to configure. You can decide which metrics you want to see. You can use the default settings also for folders, for fields that you want to see in the results. And some other, the RRE wiki will includes all the available parameters. You can tune the evaluation process. So on another workspace, I cloned the demo repository, and here we can see there is a more complete example with data from relevant search, with some data from relevant search loaded. And we have 7 iterations. What is an iteration? It's basically internal or external development iteration. At the very beginning, we would have only one iteration, the verse 1.0, 0.1, whatever you call it. And an iteration, a version, is composed by index shape, the configuration of Elasticsearch, the mappings. And here we can see that we won't start with the default configuration, it's empty, the schemaless mode. The corpora is the TMDB dataset, and we have the main input file, which is which contains the ratings. So for each topics, for each query group, for each query, we are going to describe what are the relevant documents that we expect in order to execute the evaluation process and get the evaluation measures. So if I start RRE, it will scan all the available versions, which are 7 in this case. I'm going to use, let's assume that we are at the very beginning, so we have only the version 1.0. I can use a filter in it's one of the available Maven parameters. So I can run the evaluation process using only the version 1.0. On the other side, I have the RRE console, which is basically an Angular web app which listens for evaluation data, and it gets automatically refreshed when I run a build process. So If I, oops, sorry, this is the, okay. If I run the evaluation process, you can see that here already we run only on one iteration, configuration version 1.0. And after I have to, no, sorry. The screen is not so. In the configuration file, I set only 3 metrics: precision at 1, precision at 10, and NDCG at 10. On the left side, you can see the RRE domain model. So you can see the corpus, which is called tmd.bulk. The 2 topics, Space Jam and Star Trek, the 3 query group under those topics, and finally the queries: basketball with Cartoon Aliens and Patrick Stewart and Star Trek Patrick Stewart. Here I can see the values of the computed metric. The evaluation session has been executed and RRE correctly computed the requested metrics. Okay, here I can see some information. It's not really useful until I create a new iteration, because in this way, I will be able to see in which direction my system is going, if there are some improvements. Here I can see that, for example, the basketball with Cartoon Aliens is not performing so good. Actually bad, because both the 3 measures are 0. So there is another information that the console can show you. Under each query, I can see that for each version, I can see the top N results. Red means not relevant, blue means relevant. So here I can see why we have all those zeros. So we won't enter in the details about the differences between the several iterations, but let's say that at a certain point of time, the developer, the user, created the version 1.1. Here the difference is that instead of relying on a plain schemaless mode, guessing mode of Elasticsearch, the user configured properly a couple of fields with the English analyzer. So if I enable also the second version, RRE will re-execute the evaluation version, but this time we'll use 2 versions, and we would get some comparison data. Sorry. Well, for each metric, we can see the version 0.1 and version 0.0, sorry, and version 0.1. We could see the metric value at query level and how it is aggregated at upper levels. So I can see that at corpora level, I have a loss of 0.5. So something is not going as expected. The basketball with Cartoon Aliens is still not good, because I still have all zeros. And if I see, if I expand the query, the top N result for each query, I can see that I improved the number of results, because we moved, can you see, we moved from more than 1,000 to 84. Items are still all red, so there is some difference. They are not the same documents, but we are still at that point, because you have those 3 zeros. So the developer created another iteration, let's say version 1.2. and rerunning the configuration. The configuration in this case, the difference between version 1.1 and 1.2 is in the boost that the user gave to the searchable fields in the query, not in the index shape. So once the build is completed, I can see that this time the basketball with cartoon aliens performed good, because the precision at 1 is 1. That means that the first result is good. The precision at 10 is doesn't have a good value, but if we have a look at the rating files, at the ratings that the user gave for this specific query, he configured just one relevant document, Space Jam. So from the precision at 10 perspective, this is the maximum value that we can have, because there is only one relevant document. And at the same time, this is another thing that RRE allows you to do that. You can see the effect of the iterations, not only, let's say, horizontally on a specific query, but you can see also the side effect or regressions on the other queries. And here you can see that you see some red button somewhere. So that means probably we fixed the first query, but something went wrong in some other query. Specifically, Star Trek Patrick Stewart, we see some between version 1.0 and 1.1 there has been a loss, because we moved from, this is the precision 1, the first column, and you can see that in the first iteration we had the top item which was relevant, while in the second is no longer there. So that's the reason why we lose. And in the third iteration, another item came back in the first position. The same, this is the precision at 10, the second column. We moved from 7 relevant results for version 1.0, 1.1 to 4 relevant results. So it's not so good. You can do this reiteration how much times you want. You can, the several iteration doesn't need to be necessarily releases, but it can also be experiments. So you can do things like this one, and okay, here with this monitor is not so, probably is a little bit messy, because here I'm enabling all the versions. So the result is a little bit, just a moment for the build, but probably you should have a big monitor for dealing with, for dealing with such data. It's interesting because if you want to, this actually I enabled 3 metrics, but usually you are working metrics by metrics, especially if you have a lot of queries, especially if you have a lot of versions, and in this way you can trace down a specific query, analyze why it is behaving in that way, comparing with different versions, why in the first version was good. I did 7 iterations and things are not so good. So you can do this kind of analysis. However, you can use also the filtering capability of the Maven plugin for reduce the number of iterations that you want to consider. So let's assume that we are at the end of our story. I have 7 iterations. If I run all the iteration, I get the huge, console. So I could be interested only in seeing the difference between the first and the last iteration. So a couple of months ago we had 1.0. Now, after a couple of months, we have 7 iteration. Okay, let's see what happened between all those changes. And here, probably is a little bit small, but here you can see that we have a lot of green. So green or yellow. So that means that our system is stable through the different iterations, or there has been some improvement. The Star Trek Patrick Stewart, there is something that is not so good in terms of average of precision at 10, because we moved from 7 to 4. So here there should be something that needs to be checked and probably fixed. And doing that, I can control my system, and I can avoid as much as possible regressions and unexpected, let's say, side effects of changes that I'd like to introduce for example, for enhancing some query or improving some query. It allows me to have a look at the whole system, let's say. This is, of course, a small example, because we have 3 queries. So I expect that in a production system, the rating files would contain a lot of queries, that's the reason why we modeled the RRE in that kind of tree, because it helps you to divide, to classify things in topics groups, and so on. Sometimes, like in this example, this classification is a little bit complex, especially when you have simple systems or you have few queries. And that's the reason why a lot of those nodes, the query groups, the topics, are optional. You can omit them, you can have just a list of queries. I think that it's more or less. There is also this kind of explanation. We are working on that. We are working in general on this RRE console, because here, for example, a nice addition would be to add some kind of pop-up that shows the Lucene explain, for understanding why that element is there in that position. We have a lot of ideas about how to improve, of course, the framework, and the framework is open source. So if you have some feedback, some ideas, some whatever, any feedback is warmly welcome. I don't know if you want to talk about.
We can go to the future works. So thank you, Andrea. We've seen how you can use RRE effectively on a demo project. So this example was on Elasticsearch, but that of course is valid for Apache Solar as well. So it strictly depends on your system. So you can zoom a little bit and move to the latest work. And so configuring the queries, so configuring your system, so the config set directories we've seen in this example were for Elasticsearch, but you can imagine if you have Apache Solr as a server, you will do a similar thing. So from the perspective of future works, we are working on the integration with Solr of a Rank Eval API. So basically giving the opportunity of integrating Apache Solr directly with RRE to push ratings to Solr and get back directly the ratings for your system. Then we are working on a Jenkins plugin, so this would be quite good to be integrated in your continuous integration and continuous delivery system, because you would like to see after a release, for example, how the system is going. So that would be quite good to explore the performance on the system with a quick dashboard directly from your CI plugin, so like Apache Jenkins, for example, or Atlassian Bamboo, for what matters. And one important point we are working on is how you build the inputs, so how you build your rating set. So building the rating set is actually the most tedious part, because if you do that explicitly, we will have the same problem of a learning to rank project. So you will need people, you will need experts, you will need a crowd to do that. And they're not going to like to just put lines in a JSON file. So, that's good for RRE to take it as input. It's good from a machine, not very good from a human. I mean, it's readable, but not very writable, let's say. So there are two possibilities we are working on at the moment. A judgment collector UI that will basically show to the user pair of documents given a query, and the user will be able to say which one is good and which one is better actually. Or implicit collection, so you actually get the user interactions that can be clicks, add to cart, sales, whatever is relevant in your business, and then you evaluate the distribution of them, and you extract automatically the ratings. So we have the same consideration that we saw at the Learning to Rank talk. So you will have implicit, which is cheaper, much bigger in number, but noisier, while explicit judgments is going to be, of course, much more precise if you have like a good set of experts, but much more costly. But this is a way you can improve the way currently RRE works. I mean, right now is you need to provide the JSON, and effectively you need to write it. So we are going to improve that side. And once you collect the data, so once you collect your ratings, this is actually going to be quite useful, because from the data you collect, you could actually make an integration, an indirect integration with Learning to Rank and build the training set out of the data you collected. And at that point, you will be able to evaluate your search and also actually improve your search relevancy. And this is just a brief slide about the problems you will have when you move from data, from user interactions to a rating set and possibly a training set for Learning to Rank. We don't have the time to explore it, but the slides are available, so you can take a look on your own. And the same will be how you estimate the relevance label. So for example, you want to take into consideration the clicks through rate, so impressions and clicks, for example, or bookmarks, or add to charts, sales, and based on that, understand what's relevant from a scale from 0 to 4, for example. And when you build your training set, if you want to integrate, for example, with Apache Solr Learning to Rank, you need also to extract the features you defined to build the training set to a readable way, a readable version for Solr. So you will need actually to automate that part as well. And this can be an improvement. So you collect the user interaction, and then automatically you build a training set and a configuration file for the features definition in Solr. So this is the summary about RRE, so starting from the introduction, the description of the framework, a quick demo, and some of the future worlds. And now it's time for the questions. We have one there.
For example, if I have solar, I'm using solar with RRE. What it does at the application when it starts up? For example, it will index the data in memory and then evaluate the queries and produce the report, because like it's not saved in the disk like normally it would be, right?
So the question is, if I have an Apache Solar instance configured, what will happen with RRE? Will actually it re-index in memory and have an embedded instance of Solar that will be used for evaluation, or what else? So the answer is, at the moment, you need to provide the configuration set, and effectively RRE will run and spin up in memory, so in the memory that is dedicated to RRE, an embedded Solar instance with that configuration, fill the data in the Solar instance. So effectively, it's an embedded one. So the index will be on disk, depending on the configuration. And this is one way. We are also working in integrating actually, like, instead of having to provide the configuration set and then spin up the embedded instance, trigger an existing already instance, like a QA, for example, instance. But yeah, the quick answer is yes. At the moment, you're going to embed that instance in memory, but the index will go anyway on disk.
The one thing that we probably, I don't remember if there is some slide there. RRE has a lot of extension points where you can plug in your add-on. One of those extension points is the search platform. There is a kind of search platform API which provides an abstract interface of the life cycle of a search platform that RRE expects. At the moment, we have just two bindings, which are the embedded Elasticsearch and the embedded Solar. But it's very easy, and we are working on that, to create a remote search platform for integrating RRE with a staging server, staging Elasticsearch or Solar.
Does this answer the question?
Between version 1 and version 1.1, for instance, can you change the backend actually? Can you test in one Solar and in version 2 Elasticsearch or another version of Solar?
So you mean if you switch the entire search system behind? I think I can't see a reason you couldn't, but I don't know right now if it's going to work.
There are different systems, so the comparison. Well, I'm just talking loudly because interesting question. Actually, you can't. I'm trying to imagine what is the constraint, I mean, from the code perspective. But theoretically, maybe it requires some implementation, of course, but it's not impossible. So yeah, sure.
The question was if you can compare different versions from, for example, an instance of Apache Solar, and the following version is actually you completely change your search server and it's Elasticsearch. Yes, please.
Because you can give it something like a config set in Solar or the configuration in Elasticsearch, is it also possible, for example, if you have your own home implemented query parser that you inject into Solar, can you also put that? I think you can put it in the configuration and put it on ClassPass, or are there any constraints because it's running inside your embedded Solar container?
So the question is, what if you have like a custom plugin, such a query parser in your search instance, and you want to provide that as part of the configuration set, effectively will be code. So
What? No. It plays a little bit different between Solr and Elasticsearch. Solr, the visual machine that is pinned up is just one. So basically, if you have this kind of need, you could have instead of POM packaging, like the POM package, project packaging, you could have a jar packaging, so you can have also Java code, and with your query parser or your add-on. And in the configuration set, you are just referencing those classes, and they are picked up. In Elasticsearch, we had to do some change because the embedded version of Elasticsearch requires, if I remember, at constructor time, that you give the list of the plugins. So, yeah, and the Maven plugin, the RRE Maven plugin for Elasticsearch allows you to configure metrics, fields, and so on, and plugins. So you can have your plugins in the source folder, and you can configure them through the Maven.
Okay, thanks a lot. Other questions we will have to take offline. Yeah, thanks for your talk.
Thank you.